Hello and welcome to Power Tools, Module 00104 in the core curriculum. I'm Brian Young. Let's get started. In the last module, we went over hand tools. Those are tools that are not powered except from you, screwdrivers, wrenches, pliers, saws. Now we're going to go over power tools. These are tools that have a separate source of energy, like circular saws, drill motors, things like that. So 00104, Introduction to Power Tools. After this module, you should be able to identify and explain how to use various types of power drills and impact wrenches. Identify and explain how to use various types of power saws. Describe the types of jobs best suited to grinders and oscillating multi-tools, and identify and explain how to use miscellaneous power tools. So for the performance task, your instructor is going to have you safely and properly demonstrate the use of 3 or 4 of these following tools. You don't have to do them all. Overview: power tools play an important role in the construction industry. Thousands of construction workers across the world use power tools every day to make holes, cut different types of material, smooth rough surfaces, and shape a variety of products. Regardless of their specialization, all construction workers eventually use power tools on their job. This module provides an overview of the common types of power tools and how they function. It also describes the proper techniques required to ensure their safe and efficient operation. And we should include also maintenance, keeping the tools in a good working condition. Drills, drivers. Electric tools, cordless and corded. These tools are powered by either of 2 types of electricity, alternating current or direct current. Tools powered by AC plug into a wall receptacle using an integrated power cord. DC powered tools, known as cordless tools, operate on rechargeable batteries and make up the vast majority of power tools used on today's construction sites. They've come a long way. Battery powered tools, drills, saws, have as good of an ability to perform as corded drills and saws. They're more convenient. You just grab them and go. You don't have to stretch out a drop cord. The downfall is when the battery is dead, then you have to recharge it. So it's best to have 2 batteries, maybe even 3, that you can swap out so you can continue working while you're charging your battery. Pneumatic means air. These tools are powered by air. Electric or gasoline powered compressors produce the air pressure. Air hammers and pneumatic nailers are examples of pneumatic tools. Specialty tools. These tools include powder actuated fastening tools that use gunpowder to drive pins and studs into concrete and steel. Powder actuated tools require special training and certification to use. You can't just pick one up and use it. You have to be certified. Don't let them catch you even handling one on a job site if you have not been trained. Hydraulic, that's oil or liquid. These tools are powered by fluid pressure. Hand pumps or electric pumps are used to produce the fluid pressure. Pipe benders, jackhammers, and wrenches are examples of hydraulic tools. Before reviewing specific types of tools from each of these categories, it's important to address general safety guidelines that apply to all power tools, regardless of category. Unplug them, remove the battery, take away the power source before you change bits or blades or do any kind of adjustments. Don't ever remove the guards. They're there to protect you. 1.1.0 Basic Power Tool Safety. Always remember, if not used properly, power tools have the potential to be dangerous. Safety guidelines are covered for each power tool in this module, but general safety issues, safety in the work area, safety equipment, and working with electricity are covered in the Basic Safety module. This information is vital for working with power tools, and trainees must complete the Basic Safety module before beginning this module. Warning, Module 00101 Basic Safety must be completed before studying this module. Remember that appropriate personal protective equipment must be worn when operating any power tool or when near someone else who's operating a power tool. So basic safety guidelines that will be followed when working with all power tools, including the following. Always read and follow the guidelines provided by the power tools operating instructions given by the manufacturer. Never operate power tools without proper instruction and supervision. Confirm you have the right power tool for the job. This is highlighted. Make sure the tool has been disconnected from its power source or of energy when not in use and before performing maintenance or replacing parts such as bits, blades, or discs. That's very important. Remove the power before you do any alterations to the tool. Regularly inspect power tools, including power cords and hoses, for damage. Proper personal protective equipment, including safety glasses, are required regardless of what power tool is in use. Keep other craft workers who are not directly involved with the work at a safe distance. Do not wear loose-fitting clothing that can be caught in the mechanism of your power tool. Never use electric power tools in wet conditions unless they're approved for this type of application. And then this is highlighted. It says, additionally, before plugging into any receptacle, confirm the power switch on the tool is set in the off position. This is also highlighted. If a power tool is equipped with a trigger lock, do not use the lock. A trigger lock is a small lever, switch, or part that can be used to activate a lock and catch or spring to hold a power tool trigger in the operating mode without finger pressure. It's kind of weird that they make them and then they tell you not to use them. But to be safe, don't use the trigger lock. If the power tool gets away from you and you drop it to the ground, it's going to continue running. Belt sanders and the like can skitter across the floor like a wild animal. Trigger lock is a small lever, switch, or part that can be used to activate a locking catch or spring to hold a power tool trigger in the operating mode, even when the trigger is released. Locking any power tool in the on position can be very dangerous. Never carry an electric or pneumatic tool by its cord or hose. Do not allow yourself to be distracted while using a power tool. If you're distracted or interrupted while operating the tool, turn it off. Warning, and this is a highlight, it says, the use of trigger locks may be prohibited by an employer or job site. If a power tool is equipped with a trigger lock, do not activate it. 1.2.0 Types of power drills, drivers. It says the power drill can also be used as a sander, a polisher, a screwdriver, a grinder, or a countersink. And it has a definition here. It says a bit or drill used to set the head of a screw at or below the surface of material. So it's kind of conical in shape, and it basically just makes the top of the hole a little bit larger so that the head of the screw can rest in the depression, and it hides the screw. Most common types of power drivers include the following: electric drills, cordless drills, electromagnetic drills, we'll go over them, hammer drills and impact drivers, pneumatic drills and wrenches, and electric screwdrivers. 1.2.1 Power drills and bits. Most power drills have several common features. For example, most have a pistol grip with a trigger switch for controlling the power. A lot of those switches nowadays are variable speed, so that if you depress it just a little bit, the motor turns slowly, and if you depress it halfway, it spins at about 50% speed, and if you depress it all the way, it goes to maximum speed. This front is called the chuck, and it's used to fasten the bit into place. So you use what's called a chuck key in order to open or close this chuck collar. There's the gearbox inside. We can't see it. It's inside the housing. This is an extra hand grip to give you more control over the drill. Here's the pistol grip, and here's the trigger switch. This is highlighted. It says on variable speed power drills, a screwdriver bit can be used in place of a drill bit so that the drill can be used as a screwdriver. Only use screwdriver bits designed for use in a power drill. These are different types of bits. You have a metal bit or a twist bit. This is a Forstner bit, and it makes a certain diameter size hole with a square bottom. So it makes a depression however deep you want to go, and the bottom of that hole will be flat. This is a paddle or spade bit. It has a center punch in the middle that starts the hole, and then the spade part of it, they call this a paddle bit or a spade bit. I've even heard it called a butterfly bit. This is a self-feed bit. It has a screw tip. The screw catches the wood and pulls the bit into it, and then the drill bit itself drills the hole. They're very powerful. You need a strong drill motor to run it, and make sure you have a grip on it that you can let go quickly. Don't get your thumb wrapped up in it where you're gonna twist your wrist. This is a masonry bit. I don't know if you can see the tip of the masonry bit. It has a little added piece of carbide steel here. It's used for hammering and for breaking up concrete, brick. Sometimes if you're very delicate, you can drill through tile without cracking the tile. But you have to be very careful because the tile usually has a glass coating and you can crack it very easily. This is an auger. Again, it's got a screw tip on it that will grab the wood and pull the bit into the wood, and then it will make a certain size hole, however big the bit is, 3/4 or 1 inch or 1.25 inches. And this is called a step bit. It's a self-starting step bit, so you can make different sized holes in a piece of sheet metal. Depending on how big of a hole you need, it goes anywhere from about 1/8 of an inch on up to about 1.25 inches, some of them. But each one of these steps is 1/8 of an inch usually. So we can count them and see how many it has. But it's very convenient because one bit can drill several different size holes. Here are the the twist drill bits are used to drill wood and plastic at high speed or for drilling metal at lower speed. A Forstner bit, it's a bit designed for use in wood or similar soft material. The design allows it to drill a flat bottomed hole. It's used on wood and it is particularly good for boring a flat bottomed hole. A paddle bit or spade bit is also used in wood. The bit size is measured by the paddle's diameter. A masonry bit, it's a drill bit with carbide tip designed to penetrate materials such as stone, brick, or concrete, which has a carbide tip, is used in concrete, stone, slate, and ceramic material. The auger bit, it's a drill bit with a spiral cutting edge for boring holes in wood and other materials. It's designed to turn at low speeds, is used for drilling wood and other soft materials, but not for drilling metal. A self-feed bit, a bit that uses a lead screw to pull the larger rear portion of the bit into the wood, making it simple to drill larger holes. Uses a lead screw that pulls the larger rear portion of the bit into the wood, making it simple to drill larger holes. The step drill bit is perfect for drilling holes in metal up to 1/4 inch thick. As the name implies, this bit includes different steps that allow the user to cut a hole to a different desired diameter. This is a bit that includes steps that enable the user to cut holes in metal to a desired diameter. Bits are held in drills by the drill chuck that's highlighted. It's a clamping device that holds an attachment. For example, the chuck of the drill holds the drill bit. And the keyed chucks are opened and closed using a chuck key. This is an example of a picture of a chuck key. You put this in the side, you'll turn it, and these teeth will mesh with the chuck collar. It'll open or close the jaws. 1.2.2 Cordless tools and batteries. The vast majority of tools on today's construction sites are cordless. Cordless tools offer two important benefits: safety and mobility. They're safer and more mobile because they lack cumbersome power cords that can cause people to stumble and fall. They're handy for working in areas where a power source is unavailable. So here's a cordless drill. There's the battery pack. Here's the charger. Of course, the charger does have to be plugged into a wall, but you can take the battery out and snap it in and charge it up. And usually they'll come with one charger and two batteries. That way you're always charging one battery while you're using the second one. And it says the battery pack can be detached and plugged into a battery charger anytime the tool is not in use. Some chargers can recharge the battery pack quickly, while others require extended periods of charging time. The quality of charge and the life cycle of the battery must be considered when determining how to best charge the battery. I was working on a job with some of these lithium-ion batteries, a battery drill, and you could use that drill motor almost for an 8-hour day, and it only took about an hour and a half to charge to full charge. So you can see that if you had two batteries, you'd always have a full one. Put one on the charger and use the other one for 6-7 hours. When it starts to go dead, swap them out. You'll always have a charged battery. Offering highest number of charge cycles. That's how many times you can fully charge and discharge that battery. Describes one complete charge and discharge cycle for a rechargeable battery. The term amp hour is how many amps you can use for how long. Maximum amp a battery can provide continuously for up to 60 minutes. One other critical factor to consider when using cordless tools is the battery's voltage rating. A cordless tool's voltage rating is actually a measurement of its power. The higher the voltage, the more power the tool can deliver to the job. 1.2.3 Power Drill Safety and Maintenance Guidelines. Always wear the appropriate personal protective equipment when working with drills, especially safety glasses. Disconnect the power source, power cord, or battery before performing maintenance on or changing a drill bit. Keep your hands away from the drill bit and chuck. I'm a big proponent for not wearing gloves around any rotating machinery. If you're threading conduit or if you're using a drill motor, if it's rotating equipment, machinery, you don't want to wear gloves because the gloves can get caught up in the machinery and they can twist your hand around. They can break your fingers. They can sprain your wrist. They can do a lot of damage very quickly. Warning, keep your hands away from a spinning drill bit. The spinning bit will cut your hands. Keep an even pressure on the drill to keep the drill from twisting or binding. When using a cordless drill, operate only tools that are double insulated electric power tools with proper ground fault protection. Using a ground fault circuit interrupter device protects the equipment from continued electrical current in case of a circuit fault. So, a corded drill, corded drill. It should be plugged into a GFCI, a ground fault circuit interrupter. We'll talk about it more later, but the ground fault circuit interrupter, what it does is it measures the amount of current flowing on the hot and the neutral of that power tool. And if there's a difference of even 6/1000ths of an amp difference between the hot and the neutral, it'll disconnect that circuit. It's a safety feature. If you're grounded and a small portion of the current is going through you, it'll trip that circuit and disconnect it from the power source. So it's for personal safety. Warning, do not drill into or through a wall before confirming what's on the other side. Take steps to avoid hitting anything that would present a safety hazard or cause damage. Spaces between studs, upright pieces in the walls of a building, often contain electrical wiring, plumbing, or insulation. Care must be taken to avoid drilling directly into the wiring, pipes, or insulation. I'm going to highlight that first sentence. Do not drill through a wall before confirming what's on the other side. Prior to drilling, select the proper bit for the job and make sure it's sharp. Make sure the drill bit is tightened securely into the chuck before using it. When using drills with keyed chucks, attach the key to the power cord to ensure the key is available when tightening or loosening the bit. Hold the drill with both hands and apply steady pressure. Never ram the drill while drilling because the force can chip the cutting edge and damage the bearings. As noted earlier, never use a drill's trigger lock to hold the trigger in the operating mode. Do not overreach when using a power drill. Maintain a stable and balanced stance, especially if you're on a ladder. Don't lean sideways from that ladder to try to drill a hole. If it's out of your reach, get down, move your ladder, and get back up again. Keep your power drill clean at all times. 1.2.4 Preparing to use a power drill. Prior to using a drill, make sure the one you plan to use is designed to perform the task at hand. Some electric power drills are made to be used in tight spaces, such as between studs and joists. Drills like those shown in Figure 5 are referred to as right-angle drills. So these are right-angle drills. You may not need those if you're not drilling in between studs. Caution, power drills can be dangerous if you do not use them properly. Always wear the proper personal protective equipment, including appropriate eye, head, and hand protection. Preparing drills with keyed chucks. Disconnect the drill from the power source. Turn the chuck counterclockwise until the chuck opening is large enough to insert the bit shank. The shank is the smooth part of the bit. Insert the bit shank into the chuck opening, keeping the bit centered in the opening. Turn the chuck by hand until the jaws grip the bit shank. Insert the chuck key into one of the holes on the side of the chuck and turn the key clockwise to tighten it. With larger chucks, you can tighten the individual jaws of the chuck uniformly by inserting and tightening the key in each of the holes on the chuck. Usually they have 3 positioning holes. Do all 3 of them. Don't just tighten one. Go to each position and tighten it. And you'll be surprised that each time you switch the chuck hole, you'll be able to put a little bit more tightening on it. And once you've gone all the way around, say twice, the drill bit is good and secured in the chuck. You're ready to go. So here he is. He's unplugged his drill. You can see the cord. He's putting the chuck key into the chuck, and he's turning the chuck collar, tightening the vise, the chuck, around that drill bit. Note the chuck key has a grooved ring called a gear. Make sure that the proper size chuck key is used so that the key's gear mesh with the matching gear on the end of the chuck. Warning, do not forget to remove the key from the chuck after it has been tightened. Otherwise, when you start the drill, the key could fly out and injure you or a coworker. Preparing drills with keyless chucks. Disconnect the drill from its power source by removing the battery pack before loading a bit. As shown in Figure 7, open the chuck by turning it counterclockwise until the jaws are wide enough to insert the bit shank. Insert the bit shank into the chuck opening. Keep the bit centered in the opening, turning the chuck by hand until the jaws grip the bit shank. Tighten the chuck securely with your hand so that the bit does not move. This one doesn't have a chuck key. You just tighten it by hand. And your instructor will demonstrate that for you. 1.2.5 Operating Power Drills. Put on the appropriate personal protective equipment, including eye safety and shoes. Make a small indent or mark on the material exactly where the hole needs to be drilled. Firmly clamp or support the material being drilled, then hold the drill perpendicular at a right angle to the material surface and start the drill. With variable speed drill, start the bit slowly and verify the drill is rotating in the right direction. When the bit's faced away, it should be turning clockwise. Place the tip of the bit on the indent or mark and hold the drill with both hands. Apply only moderate pressure when drilling. Figure 8 shows the proper way to hold the drill. Reduce the pressure when the bit is about to emerge from the other side of the work, especially when drilling metal. If the drill bit gets stuck in the metal during drilling, release the trigger, use the reversing switch to change the direction of the drill, and gently back it out of the material. So that's one thing we didn't cover. A lot of these drills nowadays, they have a reverse, forward and reverse. So you can reverse it and get it out. Warning: as the drill bit emerges through the opposite side of the material, be prepared for it to grab. With the power still on, the tendency of the drill motor is to rotate the operator and not the bit. Be sure to maintain firm control if this happens. Drilling metal: when drilling metal, it's best to lubricate the bit to help cool the cutting edge and produce a smoother finished hole. A small amount of non-combustible cutting oil or tapping fluid makes a good lubricant for drilling softer metals. So that's a good thing to remember. You can lubricate that bit. It keeps the bit from overheating, and it makes it easier for you to drill. Still go at low speed though. Still don't try to go too fast. 1.2.6 electromagnetic drill press. Now, these electromagnetic drills have a base that is an electromagnet. They have two buttons on here. One's the power button, and then there's the start and stop. So what you want to do is to put this where you want it, either on an iron beam or on a metal table with a hole cut out of the metal table for the drill bit. You get it positioned, and then you turn on the power, and this electromagnet will hold this drill motor firmly. It won't move. It becomes a drill press, basically, is what it does. And then you have the controls to start and stop the actual drill itself. But don't mistakenly turn off the electromagnet. Don't turn off the main power. When you do, the drill will move. This is especially important if you're drilling in a column and you're up on a ladder. When you get the electromagnetic drill in place, you turn on the power, and it holds to the side of that metal beam. If you turn off the power, or if somebody unplugs your extension cord, that drill motor is going to fall. So you're supposed to put a sign, caution, do not unplug. You put that on your cord when you're using an electromagnetic drill. Recycling rechargeable batteries. I'm not going to read any of that. Switch on the junction box controls the electromagnetic base. When the switch is turned on, the magnet holds the drill in place on any surface with magnetic characteristics, such as carbon steel. The drill base must be clean, and the surface must be flat. The switch on the top of the drill turns the drill motor on and off. A depth gauge can be used to set the depth of the hole being drilled. It operates like a drill press. Let's see here. There are several safety rules specific to mag drill presses, including the following. Securely clamp the material being drilled by the press. Unsecured materials can become dangerous flying or spitting objects. Since mag drill presses are mounted onto an electromagnetic base, it is important to maintain electrical power to the drill's electromagnet. To prevent the electrical power supply from being interrupted, attach a do not unplug tag. I'm going to highlight that. Attach a do not unplug tag to the cord. That's a highlight. Use a safety chain to secure the electromagnet drill in case power is lost or shut off. Sometimes it's not anyone's fault. It's not that someone unplugged you. The temporary power board could go down. So you need a lanyard. This tells you to use a lanyard. For using a mag drill press on a construction site, confirm whether safety attachments must be used. Some sites require shields and or safety lines to be attached before a mag drill press can be operated. So here they've got a chaining it down so it doesn't go anywhere. Warning: removing power from an electromagnetic drill while it is in use can cause the drill to fall, potentially harming the operator. Hammer drills. These are for concrete or block. 1.3.0 hammer drills and impact drivers. A hammer drill has a light pounding action that enables it to drill into concrete brick, or tile. The bit rotates and hammers at the same time, allowing faster drilling in these types of hard materials. That would be possible with a regular drill. When the hammering action is disabled on these drills, they can also perform basic drilling tasks using other types of bits. The depth gauge on a hammer drill can be set to the depth of the hole to be drilled. So, special bits used with hammer drills are designed for pounding while they are turning. As a result, the bits used for drilling holes in masonry and rock have very hard tips, which are frequently made of carbide. Carbide tipped bits are actually made by coating the tip of the drill bit with a mixture of tungsten carbide and cobalt baked at extremely high temperatures. It makes it very hard and very brittle, and it can cut through stone. Okay. The term hammer drill is often used to describe all tools that hammer and drill. However, rotary hammers are designed for much heavier jobs than a typical hammer drill. So here's a rotary hammer. These are for drilling or chipping concrete slabs, and they have specialty bits that only fit in that tool. You can't use them in any other tool. These bits are hardened steel, so you can't use these as a chisel. If you have a chisel bit, don't use it as a chisel. Don't try to hit it with a hammer, because the hammer is also hardened steel and something's going to crack. Okay, well, let's see here. They have a couple of different types here. They've got SDS technology originated in the mid-70s when Hilti and Bosch introduced a new way of fastening a bit to a hammer and rotary drill. In these early days of technology, many people insisted the letters SDS stood for the German words Strecken, Dreschen, I don't speak German, so you'll have to translate these yourself, which translates to insert, twist, and secure. Today, SDS is known to refer as slotted drive system. When it was introduced, slotted drive systems allowed rotary hammers to lock a bit into place while still allowing the bit to move up and down. Because the chuck was spring-loaded, SDS bits could be pushed into the chuck without having to tighten them. The next evolution of the system came with the introduction of SDS Plus, which offered an improved connector, yet remained backward compatible with standard SDS bits. Finally, the SDS Max system was introduced to handle the heaviest masonry and steel drilling jobs. SDS Plus bits range from size 5/32 to 1 1/4 inches, with thin wall carbide core bits up to 4 inches in length. SDS Max bits range from 1/2 inch to 2 inch, with thick wall carbide core bits up to 4 inches in length. 1.3.1 Hammer drill safety and maintenance. Of course, always wear the appropriate personal protective equipment when working with hammer drills, especially safety glasses and hearing protection. Never operate hammer drills or rotary hammers with one hand. Use both hands for maximum control. And again, I say don't wear gloves. Don't wear gloves if you're using any rotating machinery. Do not operate hammer drills or rotary hammers near flammable materials. Sparks generated by the bits may ignite them. Use a clamp to secure smaller or lighter workpieces, and never hold a workpiece with any part of your body. Always disconnect the hammer drill from its power source before changing bits or making any adjustments. Check the hammer drill and bit for damage prior to using it on the job. Make sure you're using the correct bit for the job. Using regular non-masonry bits on concrete can damage or destroy the bit. 1.3.2 Operating hammer drills. This is highlighted. It says if the hammer drill is being used on concrete or similar materials that produce airborne dust, there are important silica exposure standards that must be followed. You should be wearing a respirator or a half face mask. Silica exposure standards are outlined in the basic safety module. Use the following steps to operate a hammer drill. It says don the appropriate personal protective equipment. Ensure you have selected the appropriate drill bit for the job. If you need to replace the bit, disconnect the drill from its power source prior to doing so. Once the bit's been replaced, reconnect the drill to its power source. Make a small indent or mark on the material exactly where the hole needs to be drilled. Set the number of blows the bit will exert each minute. Set the drill to turn slowly. Place the tip of the bit on the indented mark, then apply pressure on the drill against the surface. Drill a guide hole until it is approximately a 1/4 inch deep. Adjust the speed of the hammer drill to the desired speed and finish the job. Clean out the hole when finished. Let's see here. 1.3.3 impact drivers. Impact drivers are usually lighter and more compact than common power drills and hammer drills. They also apply more torque when fastening screws or bolts. As a result, impact drivers are excellent tools for driving or loosening large numbers of fasteners, screws, nuts, or lag bolts. They're also a good choice when working on harder surfaces, such as pressure-treated lumber, hardwoods, or even steel. Unlike most power drills, they typically do not offer variable speeds, which makes an impact driver less suited for jobs requiring precision or detailed work. Caution: impact drivers generate much more torque than regular drills. As a result, they can split, break, or rip through softer or more brittle surfaces. Be extra careful when using an impact driver to attach fasteners to wood or softer materials. 1.3.4 Impact driver safety and maintenance. Always wear the appropriate personal protective equipment when working with impact drivers. Read and understand the manufacturer's manual. Clean the impact driver before using it. Ensure the proper accessory is used for the job. Confirm the fastener and material you're drilling into will not be damaged by the torque generated by the impact driver. 1.3.5 Operating impact drivers. Don the appropriate personal protective equipment. Select the appropriate bit or attachment for the job. Disconnect the drivers from its power source. Pull the collet forward and insert the bit. Once the collet snaps back into place, the bit is attached. I would test the bit first. The collet goes back into place. Pull on that drill bit. You should not be able to pull it out of the impact driver. Reconnect the driver to its power source. Set the direction you want the bit to turn, tighten or loosen. Place the bit or socket squarely on the fastener. Start the tool slowly and release the trigger when the fastener is attached or removed. Driving the fastener too hard can damage it. 1.4.0 Pneumatic drills and impact wrenches. Remember, pneumatic is air. Pneumatic tools are powered by compressed air. An air hose transfers the compressed air from an air compressor to the tool. Pneumatic tools tend to have more power for their weight than comparable electric tools. 1.4.1 Pneumatic drills. I'm going to read the highlight here. It says, these drills are typically used when there's no available source of electricity or when a high rate of production is necessary. They're also used in environments where you have an explosive environment. Electric drills create sparks. Pneumatic drills do not. So whenever you go and get your car worked on in the shop, you'll hear that they're using pneumatic tools. That's because of gasoline vapors. They don't want to use electric tools in the shop. They use pneumatic. 1.4.2 Impact wrenches. Impact wrenches are available in pneumatic and electric, corded and cordless. Both types are used to fasten, tighten, and loosen nuts and bolts. Like pneumatic drills, pneumatic impact wrenches must be connected with a hose to an air compressor. The speed and torque of these wrenches can be adjusted based on requirements for the job. Electric models lack the strength of pneumatic wrenches, but they are easier to maintain, especially since there's no need to service hoses and compressors. So here's a battery-operated impact wrench. While pneumatic impact wrenches have traditionally been more popular than their electric cousins, advances in battery-powered technology make cordless wrenches a more viable option today. Some of the most advanced cordless impact wrenches can generate up to 1,500 foot-pounds of breakaway torque. Although this is nowhere near the forward torque available on some larger pneumatic wrenches, it still provides a convenient and strong alternative for smaller jobs, and you don't have to carry around an extension cord or an air hose. So they're very convenient. 1.4.3 Pneumatic Tool Safety and Maintenance Guidelines. Always wear the appropriate personal protective equipment, including eye, hand, and ear protection. Review the manufacturer's instructions provided with the pneumatic tool. Before changing attachments or performing any maintenance on the pneumatic drill or impact wrench, make sure the air supply is turned off and the tool is physically disconnected from the supply hose. Make sure that the workpiece is secure and always maintain a balanced body stance when operating the tool. Regularly check the air hose for damage. Keep your hands away from the working end of the tool. If you're using a pneumatic wrench to tighten a bolt and nut combination, use a backup wrench to keep the bolt or nut from spinning. Confirm the air supply is clean, dry, and at the proper pressure. Keep the drill or wrench lubricated. Use only drill bits and impact sockets that are designed for use with the tool. Warning, the amount of air pressure used to power a pneumatic drill is higher than the OSHA recommendation for cleaning a work area or similar activities. Improper use of pressurized air can lead to injuries as well as damage to the tool or materials. I think OSHA says it has to be regulated to no more than 30 psi. If you're using it to clean off a work area, you're never supposed to use compressed air to clean yourself. A lot of guys come in from the field and they're dusty and dirty. They just take the compressed air and they blow off the dust before they go in to the brake trailer. That's not allowed by OSHA. 1.4.4 Operating pneumatic drills and impact wrenches. Don the appropriate personal protective equipment prior to operating the pneumatic drill or impact wrench. Ensure that there is an oiler if the tool requires one, either at the air source or at the tool. Confirm that the oiler is set properly. Attach the appropriate bit or socket to the tool. Make sure the pneumatic connection between the tool and the supply hose is secure, and install a whip check as required. A whip check is a safety attachment used to prevent whiplashing in hoses that are inadvertently uncoupled. So here's a whip check. You put that on the hose, and if you're attaching two hoses together, this end goes on the other hose. It keeps them from separating and becoming wild, thrashing. They're going to hurt someone. Warning, the air hose must be connected properly and securely. An unsecured air hose can become loose and whip around violently, causing serious injury. Some fittings require the use of whip checks to keep them from coming loose. Confirm the compressor's regulator is set to the appropriate pounds per square inch. Also, if tightening a bolt or nut, check the recommended torque specifications prior to using the tool. Warning, when only impact sockets made for pneumatic, use only impact sockets made for pneumatic impact wrenches. Using handheld sockets can damage property and cause injury. And then grip the drill or wrench firmly before operating the tool, and when you're finished using the tool, disconnect it from the air hose. Section 1 review. The trigger lock on power tools should never be used to lock the trigger in the on position. True. The part of a power drill that enables a user to back out a drill bit when it is stuck in the work material is called the reversing switch. An improper important difference between hammer drills and rotary hammers is where is it? Rotary hammers have specially designed chucks. Well, I think so, but have key chucks. Hammer drills are designed for heavy duty jobs. Rotary hammers turn faster. I'd say rotary hammers specially designed shops. You can only use the bits made for that rotary hammer, and you can't just use any bit. A pneumatic powered tool that is best suited for fastening, tightening, and loosening nuts and bolts is an impact wrench, pneumatic impact.